Welcome to video 6.1. We're just getting started with our next unit here, and it's really important to keep up because the work that we're doing is going to get mathematically more intense pretty quickly. And so preferences, hopefully, they don't seem too foreign and they're fairly easy to grasp, but we'll be building on them as we go along in this unit of constrained optimization. So today we're going to talk about preferences, preference maps, and indifference curves, and these are kind of like the foundations of consumer choice and how economists study how people make decisions. And so we're going to get into that. Some applications of preferences that you probably or maybe have seen in the real world are like, one is medical school residency matching. So in when you're in medical school and you get done with your degree, something you have to do is go be in residence at an actual hospital. And what people do is they write down rank ordering of their preferences over places to be a resident. So they write down, they rank where they would prefer to be. College choice, so you're choosing amongst alternatives and you can only pick one and you have to choose amongst all your different alternatives. And then another one would be like choosing fast food. So narrowing it down, just a quick story on this. My parents got me a book called Cheap Psychological Tricks for Christmas. And one of the tricks was, if you want a quick decision, give just two choices because it's easier to compare A to B than A to B and C. So like A would be McDonald's, B Burger King, and C would be like Five Guys. It's easier to compare McDonald's to just Burger King because you only have to compare along one thing. But anyway, so when we're talking about preferences in economics, we mean what people want and need. And this really has nothing to do with the budget or affordability. It's more just like what they like and what they need to survive. And so we know that these preferences can shift the demand curve as they change. So one of those things where there's been an increase in preferences for is energy drinks. Like 30 years ago, it was just coffee, but now there's an increasing preference to have energy drinks. And so that's shifted the demand out. And on the opposite side, there has been a decrease in the preferences for horseshoes. And so that's shifted demand in over the last 100 years. And so three properties of preferences that we need to know are completeness, transitivity, and then the third one we'll use is more is better to simplify our analysis. So what does completeness mean? Completeness just means that individuals can rank all pairwise comparisons. So they can compare A to B, and they know which one they would rather have. So specifically, this would be like the A is preferred to B, or A is weakly preferred to be. So the symbol for weakly preferred is this kind of like greater than sign, curved greater than sign with a kind of this squiggly underneath, and that just means weakly preferred to instead of like strongly preferred to. So weakly kind of allows there to be ties. And so it just means that if there's two options, you know which one you want more. If there's three options, you can compare all those options as well. So this just rules out indecision between two choices, and it might be easiest to see this with some examples. So for one, let's say that you can choose between soccer and basketball. You prefer soccer to basketball. Two, let's say you're comparing a 10-year sentence in jail or a life in jail. You can say that you prefer 10 years sentence to actual life in jail. And then for our dog example, we can say that they prefer a treat to a pet. And so they can rank these comparisons, and it's easily extendable to three options. And so in all these three scenarios I showed you, the decision maker was able to rank between the two choices. And if there's three choices, say soccer, basketball, and football, you just need to be able to rank soccer to basketball, soccer to football, and basketball to football. And so we could say soccer's better than basketball and soccer's better than football. And then we could also say, okay, well, we like basketball better than football. And note that if you're comparing soccer to basketball, it also implies a basketball to soccer comparison, so the other way around. And something you might have noticed with having three options is that if A is preferred to B and A is preferred to C, then it kind of implies something for how B is compared to C. And so for there to be a well-defined relationship, then there has to be logical consistency. And so that just means that if you prefer A to B and B to C, then you must prefer A to C, because A is greater than B and B is greater than C. So then A must be preferred to C. And so if you prefer soccer over basketball and basketball over football, then you must prefer soccer over football. If that were the case, then we could say that your preferences were transitive and complete. And so let's say we have, you can prefer a 10-year sentence over life in jail and life in jail over the death penalty. Then transitivity implies that you must prefer the 10-year sentence to the death penalty. And then finally, if you prefer treats over pets and pets over the crate, then you prefer treats to being in the crate. And that would be transitive preferences. And if we have those two things, complete and transitive preferences, then we say that the preference relation is rational. And so the consumer has well-defined preferences between any pair of alternative choices. And so let's get in more to the nitty-gritty of what this means kind of graphically. And an easy way to think about this is the third preference relation that we need, and that's just that more is better. So it means that having more of something is preferred to having less of something. And this appears true for most people. And if you can freely dispose of things that you don't actually want to consume, then no one is any worse by having more. And this just simplifies our analysis. So let's start with preference maps. And so preference maps are going to be really important. We can visualize the relationship between bundles of goods using these things. Let's consider a hypothetical bundle. So 2 soccer jerseys and 2 basketball jerseys. And we know that more is better. And so what's that mean? That just means that, let's say we have a point B where we have more of both, where we have an additional basketball jersey and we have an additional soccer jersey. And we can see that we have an additional soccer jersey, so we're up of point A, and we have an additional basketball jersey, so we're to the right of point A. And so we're farther away from the origin, which means we have more stuff. And from knowing that more is better, we can conclude that B is preferred to A, because you have more at B than you do at A. And so kind of by likewise logic, you can look at point W here, where we have a less soccer jersey and one less basketball jersey. And we conclude that we'd rather have point A, 2 jerseys of each, than 1 jersey of each at point W. And so you can kind of probably guess where this is going now. Point C here, we have more of one and same of the other. So we know that point C would also be preferred to point A, because, or at least weakly preferred, because we know that they have more soccer jerseys at point C than at point A. And at point D, you have more basketball jerseys and the same amount of soccer jerseys, and so you're better off at point D as well than at point A. Now let's consider point Y, where you have 1 less soccer jersey and the same amount of basketball jerseys. Well, we know you're worse off, and so you're less preferred at point Y than point A. And finally, point Z, you have less of 1 less basketball jersey and the same amount of soccer jerseys, and so we conclude that A is weakly preferred to Z in this picture or scenario as well. And so the next thing you can kind of do with these preference maps is you can compare preferences over bundles of consumptions. And so we're going to do that with 2 different people. One is named Howard and one is named Flynn. And so let's say that we have a point here on our plane of goods, number of consumed of both goods, good 1, soccer jerseys, good 2, basketball jerseys. And so there's a 0.55 where you have 5 basketball jerseys and 5 soccer jerseys, and a 0.81 where you have 8 basketball jerseys and only 1 soccer jersey. And different people can have different preferences over these different bundles of goods. And so we're going to consider these 2 bundles, and I'm going to call 5.5 point A and 8.1 point B. And so let's originally considered a point for Howard. So Howard, he's indifferent between the 2 bundles, 5.5 and 8.1. So that means he gets equal satisfaction from consuming either 5.5, 5 soccer jerseys, 5 basketball jerseys, and equal satisfaction from 8 basketball jerseys and 1 soccer jersey. It's worth trading off some additional, or he gets the equal amount of satisfaction from trading off 4 soccer jerseys to get 3 basketball jerseys. And so that's why there's this one line between these 2 points, because at every point on this single line, he gets the same amount of satisfaction. And so we know that either of these bundles is better than a bundle at 4, 4, because you've got more here and they're on the same indifference curve. And so just by knowing those two things, you know that Howard prefers either 8 basketball jerseys and 1 soccer jersey, or 5 of each, 2, 4 of each. And so they're getting more, and so Howard is getting more satisfaction at either of these points than this point at 4, 4. That just comes from knowing that Howard's indifferent, he gets the same amount of satisfaction between these 2 points. And so let's say Flynn, on the other hand, let's say that Flynn actually prefers 5, 5. So he doesn't think it's worth it to give up 4 soccer jerseys for 3 basketball jerseys. It's just doesn't give him the same amount of satisfaction. Well, then we know that the indifference curves for Flynn are going to look a little different, because 5, 5 and 8, 1 are not on the same curve. And he preferred to have 5, 5. So we actually know that Flynn's indifference curves look like this, and where there's a higher indifference curve at 5, 5 than at 8, 1. And so he's getting more satisfaction from this 5, 5 than from this 8, 1. And so indifference curves are these things that we can draw through bundles of goods, and on the same indifference curve, every bundle of good has the same satisfaction. So it describes satisfaction, utility, or happiness at all these bundles of goods. And so we have indifference curve H, M, and L for high, medium, and low. We know that high has the highest satisfaction among all points, and low has the lowest satisfaction. But it's the constant on low and high. The constant is just higher on high than it is on low. So at every point on a difference curve, call it UH or U1, we know that utility equals the same constant number. And so just from this, we can tell that point F is preferred to point A or B or C or D, but that happiness at A equals happiness at B equals happiness at C equals happiness at D, and that all these points on UM have more satisfaction than any of these points on UL. And so that's kind of more of the in-depth on just indifference curves that we've built out kind of in this class so far. And these curves have these properties, bundle, and I've shown you these. Bundles on indifference curves farther from the origin are preferred to curves closer than the origin. That's the UH is better than UL. The indifference curve cannot pass through. There is an indifference curve through every possible bundle. Indifference curves cannot cross, and the homework asks you to think closely about why that is. The indifference curves all slope downwards. Think about what an upward sloping indifference curve would mean. It would mean that having more gives you the same amount of utility, which is kind of against the assumption we've made that more is better. And they cannot be thick. And you should also think about what that means, what a thick indifference curve would mean, especially for the more is better assumption. And that's in the homework. And I don't want to discount that there is some behavioral aspect that economists have begun to incorporate into consumer choice, where we add insights from psychology and research on cognition that can be useful for understanding decision making. Some examples like are novelty and or children. So sometimes they don't have transitive preferences, and you can blame those things on novelty of goods. Another one would be endowment effect. So you value items you own more than value them in a store. You have just like this preference for keeping what you already own. It's kind of similar to the idea of reference dependence and preferences, which is a topic of the discussion board. And we can reduce the effect of endowment effects by having higher volumes of trading, by gaining experience. And then salience, so you're more likely to consider well-presented information. Decision-making has a cost, and you can model that. But if you make it easier for people to learn information, then they're more likely to consider it when they make their decisions. And so something kind of related to that is bounded rationality. So you have a limited capacity to solve complex problems. Um, and we still think that you carefully think about decisions, like, especially if it's worth it. Like if there's taxes on a big purchase, that would be a big expenditure in terms of tax money for you. And so these are kind of twists on the model that I've shown you earlier. But one of the reasons that I still think that the model that without these behavioral economics um, tweaks is useful is that rats are rational. So rational is person specific. So what may be in the best interest is not necessarily in the best interest for others. Economics rational just means that you have complete and transitive preferences over choices or bundles of goods. And we know that rats actually have complete and transitive preferences over root beer and water um, in this economics research article published in 1975. So for over a long time, we know that a human or a species less cognitively complex than humans is still able to have rational and transitive preferences. And that'll be a part of the discussion board next week, I'm pretty sure. But anyway, that's all I have to say. Make sure that you kind of understand the gist of preferences, because next week we're going to get into more utility and starting to lay the foundation for how we choose optimal bundles given our income and prices and preferences over goods. And so that's coming up. So thank you for tuning in, and we'll see you on Thursday.